So this week we're going to discuss about chapter 6. It's about a basic 2D platformer. Uh, so to begin a to begin creating a basic 2D platformer game in Unity, you basically need to create a new Unity project. From the when you open the Unity Hub and select new project, from the options choose 2D mode. This setup is important because it optimizes Unity for 2D game development, such as handling 2D sprites, physics, and UVA elements that you'll use in this platformer. uh, Another thing is create folders for sprites and scripts. Organizing your files this way will help you keep your project neat and manageable. And next step would be adjusting camera settings. So by default, Unity's camera is set up for 2D scenes, but for a 2D platformer, you'll want a flat view. Although you don't need to change the camera right away, it's helpful to adjust the camera size to 4. This makes the scene fit better for platformer gameplay. You might find the camera icon in the middle of the scene distracting. To hide it, go to Gizmo's menu at the top of the scene view, and you can disable the uh, camera icon display. Gizmos are icons and markers in the editor that can help visualize game objects, but sometimes can clutter the view. And yeah, save your project. So in the next steps of the project, you'll import art assets that will act as visual elements of your game. This includes background images, characters, platforms, and any other graphical elements. Once imported, you'll start building core mechanics such as moving the player, animating sprites, and allowing the player to jump between two platforms. So yeah, we set up a new project in 2D mode, create scripts folder to organize assets, and adjust the camera size to 4 for a better view, and disable the camera gizmo if it clutters the view, and save the scene. So next topic would be setting up graphics for 2D platformer. So we'll focus on two main tasks here. First one is placing the scenery like the platforms and importing the player character sprite. So let's discuss step by step. First is start with a simple blank image. You'll need a basic white image that acts as a placeholder for the platforms, which are the surfaces which which are the surfaces the player will run and jump on. And you can download the any blank PNG file. I think there are few images in the from the textbook, and import it into the sprites folder of your Unity project. And Unity should automatically recognize the image as a sprite since we are looking in a 2D project. We are working on in a 2D project. You can double check this by selecting the image and looking at the import settings in the inspector. And next is placing the floor. So you can drag the blank PNG file image uh, from the project view to the scene view, and this will be the floor of the platform game. And position the floor to align it with the bottom of the screen. And you can to stretch this image and make it long like a floor, scale it, set its scale in the transform component. And you can rename this object to floor to keep this things organized. And next is adding a block, which is a platform. So similarly, drag another instance of a blank PNG into the scene to create a platform above the floor. So set its scale to make it smaller block like platform, and position the block so that it's above the floor but of the side, and you can rename this. Next step would be importing the sprite sheets for the player character. I think textbook has a stickman png file. It's basically a sprite sheet is an image that contains multiple frames of an animation, for example walking or idle cycle. So this in this case we are using a sprite sheet for a simple stickman character. So import the stickman png file into sprites folder by just dragging it from the files to the Unity project view. And when you select the stickman png sprite in the project view, in the inspector view, change the sprite mode from single to multiple, since the image contains multiple frames for animation. And when you click the sprite editor button in the inspector, this opens up a new window that allows you to slice up the sprite sheet into individual frames. And when it comes to slicing the sprite sheet in the inspector editor, when you click on the slice button at the top and set type to grid by cell size and enter 32 32 by 64 for the cell size, and this tells Unity to divide the sprite sheet into frames that are 32 pixels wide and 62 pixels tall. So after slicing, just click apply to save changes and choose and close the sprite editor. So now the sprite sheet is split into individual frames. You can view these frames by clicking the arrow next to the stickman png in the project view, and drag one of the frames such as player first idle frame into the scene to place the player character, and position the player character in the middle of the floor and name the object as something like player. Now your player character is placed in the scene standing on a floor, and is ready for next steps like animating and controlling it in a game. So this setup gives you the basic layout of a 2D platformer with a simple floor, a block platform, and a player character sprite. Next, we'll move on to adding functionality like player movement and animations. So moving the player left and right in a 2D platformer. So in this step, we will discuss about creating a basic movement for the player, allowing them to move left and right using the arrow keys or A and D keys on the platform. We'll also ensure that the player collides with objects in the environment like the floors or blocks. So for our player to move and interact with an environment, we need to give the player two components. First one is rigid body 2D, and we need to have a box collider 2D. So rigid body 2D is basically tells Unity that the player should be affected by physics like gravity and collisions. And the box collider 2D is this defines the shape of the player for collision detection. So first step would be you select the player object in the Unity scene, and in the inspector window, click on the add component and choose physics 2D, and you'll find rigid body 2D, and you can set the so in the rigid body 2D component, we'll modify a few settings like the gravity scale, we'll set it to 0. We will reset this later when we want gravity to pull the player downwards. And you'll also set the collision detection to continuous to ensure smooth collision handling. And in the constraints section, freeze the rotation Z. This prevents the player from tipping over or rotating due to physics. And the last step would be the player also needs a box collider 2D so that it can interact with other objects in the scene. And when you click on the add component again, go to physics 2D and you'll find box collider 2D. This will define the boundaries of the player for collision detection. So then now the player is ready to move. Next we are writing the script for keyboard controls. We should now create a script that allows the player to move left and right using the keyboard. So let's go to the script. So in this, we have a float speed, which are public variables. These are the public variables. So float speed is this variable. This variable basically controls how fast the player moves when you press keys. So you can modify the speed value directly in the Unity's inspector. And we have private variables, private rigid body 2D, 2D body. This variable stores the reference to the player's rigid body 2D component, allowing us to control the player's movement using physics. And in the start method, we use the void start because this method runs once when the game starts. Inside this method, we use get component, uh, rigid body uh, rigid body 2D to find and store. We'll discuss other lines in the later in the later, because uh, the whole code is setups, but we'll discuss few lines now, and the later we'll discuss other. So get component rigid body 2D is to find and store the rigid body 2D component of the player. So this is necessary because the player movement will be applied to the rigid body. And in the update method, uh, so update method runs every frame of the game continuously, checking for player input and applying movement. So we have input dot get access. So horizontal, which is horizontal. This reads the player's input from the arrow keys or A or D keys. It returns a value between -1 for left movement and 1 for right movement. And we have a movement calculation. So delta x stores the input value multiplied by the speed. Uh, so this gives how far the player should move left or right. And we have a vector 2 moment. We create a new 2D vector, which where the x value is set to the horizontal moment, which is a delta x, and y value is set to current vertical velocity, which is body dot velocity dot y, and which we don't want to change the y value because we haven't added jumping yet, but it's still in there. So body dot velocity, this applies the calculated movement to the player's rigid body 2D component. So the velocity of the rigid body is its speed and direction of the movement. So changing this moves the player. And so the player also needs to interact with the floor and the block. For that, we add colliders to these objects. We select the floor and the block in the scene, and in the inspector, click add component physics 2D, and you add the box collider 2D. This adds the collision detection for the floor and the block, so the player can collide with them. So when you press left or right keys, the script reads the horizontal input and moves the player in the corresponding direction by changing its velocity. So the rigid body 2D handles the actual physics simulation, and thanks to the box collide 2D components, the player will collides with the block and the floor. So if you test the game, you'll see the player moves right and left when you press the keys, and stops when they collide with the block or a floor. So next steps would involve adding vertical movement, which is jumping, and animating the player's action based on the input. So next is playing the sprites animation in Unity. So to give your character movement, it's essential to make the sprite animate rather than just sliding across the scene. We'll be using Unity's mechanism animation system designed for setting up complex animation networks with minimal coding. So first, let's understand Unity's mechanism animation system. So mechanism in Unity is Unity's animation system, uh, designed designed to handle complex character animations. Um and we have animation clips. These are the individual loops that will be placed like walking or idle. We have animator controller. Animator controller controls when and how animations are played through a state machine, managing the transition between different animation states. So next would be importing and creating animations. So Unity can automatically create animation clips and an animator controller will when you drag multiple frames into the scene. So first step would be expand the stickman sprite sheet and set the frames to 0 and 1 for idle animation, and drag them into the scene and name the clip stickman idle, and Unity will generate a clip and a controller and delete the extra object Unity creates in the scene and keep the animator controller, and select the frames to 2 to 5 for walking animation. So when you drag them into the scene and name it like stickman walk, and also remember to delete the extra object again, but keep the animation clip. So and next is setting up the animator for the player. So apply the animator controller to the player by selecting the player object in the scene, and you can add the animator component, drag the stickman controller into the controller slot, and when you open the animator window, from the window animator animation, you'll find animator window, and add the walking animation clip by dragging the stickman walk clip into the animator window. The idle animation clip will already be there. So by default, the idle animation may play too fast. So select the idle animation in the animator window and adjust its speed to 0.2, something like that in the settings panel. So with these, your character will smoothly transition between idle and walking animation. We'll discuss other next topics in the next class. Uh, that's